Hello everyone, I'm Rupeng An. Today I'm going to talk about how we can use LangChain to build different retrieval-augmented generation or RAG systems. Let's get started. So first we're going to build a basic retrieval-augmented generation or RAG pipeline. And later on, we're going to expand that pipeline and try to address various limitations about this naive RAG to build more comprehensive and powerful RAG system. So first, you need to, if you haven't done so, you need to install the Chroma. And Chroma is a local vector database that we are going to use, as well as the face, FAISS. So we showcase how you can install face, another vector database that is open sourced and easy to use. So check my previous videos if you don't know how to install face. So basically, it should be pip install face CPU. And then we import a number of modules, most of modules from LangChain. Um, and here we also import a few other modules, and those modules are going to be useful when we build a RAG pipeline to translate question into SQL query and be able to inquire the invoke the SQL RAG pipeline. Okay, so let's first started by building our first naive RAG. We load the document using the text loader. I have a txt file, teaching with generative AI.txt. It's already in my folder. It's a very simple txt file. I use text loader to load it, and then I split the document into chunks. If you are unfamiliar with this process, data pre-processing process, take a look of my previous video recordings on how to chunk and a file and store that in a vector database. So I used a recursive character text splitter uh, um, to build a text splitter and with a chunk size of 1,000 character and the overlap of 20 characters. And then I use the text splitter to split the documents, basically chunk the document into equally sized pieces or chunks. And then I define an embedding model using the OpenAI embedding. And then I create a vector store using the face, FAISS. Make sure that you provide both your chunked documents as well as your embedding model. Right? So let's do this. First import a file and then load the document. And then we can create a retriever. So this is very easy. We just build a retriever on top of the vector database we just created. And then you should be able to fetch document from the retriever. So for example, you may look for documents that are similar to the query. The query is, should a faculty member explain the AI policy in the class? Let's see by default, how many documents are retrieved, and also take a look of the first document, right? So there are a total of 4 documents retrieved. I think probably that is the default. And then if you take a look, the first document retrieved is this. So this is the first chunk that the retriever thought is relevant. So it's retrieved for your access. Okay. And you can use the K parameter to limit the number of retrieved documents. So here I would say no, retrieve only 2 documents. And then if I evoke the retriever using the same prompt, instead of returning 4, it's returned 2 documents. Okay, and now since we have the retriever to retrieve documents, we just need to apply a LLM so that we can answer the question based on the retrieved documents. I use the chat prompt template to create a template we can reuse. And the template is very easy. It just says answer the question based on the following context. The context is just a document that you retrieved, and the question is the user input. And then I choose a chat OpenAI model, and then I create a chain to chain the prompt template with the chat model. And then I initiate this retriever to get the documents. And then finally, I can evoke the chain so that the chain is going to basically link the question to the retrieved documents. And then the chain will be able to answer that particular question should the faculty member explain the AI policy in a class based on the retrieved documents, right? Because that is what is mentioned in the prompt template, right? So let's try this. And then the response is, yes, a faculty member should explain the AI policy in class. Okay, so that is pretty good. It's a very succinct answer based on the retrieved documents, so that the user won't have to go through all these 4 different files, different retrieved documents to understand, but get a very succinct answer. Right? So as we are familiar with the above process, we can incorporate the above pipeline into a function. Remember, we always use the decorator chain when we create a pipeline using LangChain. And then we can define the QA function, which asks for a question as an argument. The question is first going to go to the retriever in order to get the relevant documents. So notice that here I use the get relevant documents function. So it's going to retrieve the documents directly. And then after that, I can invoke the prompt. Evoke the prompt template by providing the documents for the context and the question for question. And then I can invoke the chat model. So that is a very simple function, but remember, because this is a LangChain function, so when you evoke the function, you cannot say QA and then provide a question. You have to say QA.invoke because this is a LangChain function. And then you can print out the response if we do that. For some reason, I have to rerun this because it's not updated. So if I rerun the import modules, I should be able to run it with no problem. Okay, so see here, yes, a faculty member should explain the AI policy in a class. Okay. Okay. And you can, if you're interested in what documents have been retrieved, of course, you can retain the retrieved documents. So nothing changes from the previous function, except that now I add the retrieved documents. So you can take a look. You can take a look of the number of documents retrieved and also print out the documents. So see here, actually it retrieved the 2 documents, and then it print out the retrieved 2 documents here and here, right? Okay, so in the previous session, we talked about how to create a naive pipeline, RAG pipeline, but in production setting, a user is often provide query in an incomplete, sometimes ambiguous or poorly worded manner that may lead to model hallucination. So we can build a pipeline to transform the query so that the query would be no better presented. And that may improve the efficacy of the RAG pipeline. So there are many ways we can do the transformation query. One is is called rewrite, retrieve, and read. So the rewrite, retrieve, read strategy proposed by Microsoft research team simply prompts the LLM to rewrite the user's query before performing the retrieval. So the idea is very simple. That's implemented. Uh, first, no, that's demonstrate using the previous written function, the QA function, but this time the question is wordy and is pretty worded. So the question is, I don't know what to say. The weather is perfect for a walk. Should faculty declare the AI policy or not to their students? So let's see whether this this naive chain will be able to still capture a good response. Uh, so it seems that this time it works. The response still adequate, although I have some leading nonsense here. But sometimes it works, sometimes it doesn't, because the question is pretty worded. Now let's try to add a prompt to add um, a template to rewrite the prompt before feeding to the retrieval. So here I create using the chat prompt template, I create a prompt, provide a better search query for the vector database search engine to answer the given question, and the queries with double asterisk, and then question here and answer here. So basically, this prompt try to clean up the original question a little bit, so that it's formatted well. It reduces the nonsense as here, so it may lead to better retrieval outcome. And then we want to feed this prompt to a large language model, and the model is going to rewrite the question, and after that we can do some cleaning by using this simple function parse writer output, so that the rewriter chain is going to provide a clean slate for the question. So let's try this out. I'm still using this tablet written question. I don't know what to say. The weather is perfect for a walk. Should faculty declare the AI policy or not to their students? But this time, notice that I changed the rewrite prompt template with the language model, and then I also parse the writer output to see whether this provides us a better slate for the question. Yes, it does, right? So here it removed the I don't know what to say, but it's perfect for a walk. It make it the question more clear. Should faculty declare the AI policies to the students, right? So this is great. And then if you want to add the rewrite prompt template into a function, of course you could do that. So here, I first invoke the rewritten question to rewrite the question, and then I feed that rewritten question into the retriever to get the retrieved documents. And I also embedded the rewrite written function as the function instead of using the original question. So let's try this out. Still use the question, I don't know what to say, the weather is perfect for a walk. Should faculty declare the AI policy or not to their students? And let's try this rewrite chain. And great, so we get the correct response. That is, yes, faculty should declare the AI policies to students, right? Okay. And the multi-query retrieval is another way that we can stabilize the RAG output and make it more comprehensive. So the rationale is that a user's single query can often be insufficient to capture the full scope of information required to answer the query comprehensively. So the multi-query retrieval strategy resolves this problem by instructing a large language model to generate multiple queries based on a user's initial query, and then executing a parallel retrieval of each query from the data source. Remember, we can use the batch mode when invoking the chain. So that the batch mode is going to retrieve documents based on each of the queries, each of the LLM generated queries, okay, in a parallel fashion. It's still going to be pretty fast. And then finally inserting the retrieved results as prompt context to generate a final unified model output. Okay, so that is the idea. So basically, the multi-query retrieval is going to create different versions of the original query, and then use each different version to retrieve in a parallel fashion a number of documents, and then compile them together, and finally allow LLM to generate the final output based on those retrieved documents. Okay. So the multi-query retrieval is particularly useful for use cases where a single question may rely on multiple perspectives to provide a comprehensive answer. Right? So let's try this out. First, we create a so-called perspectives prompt temp that are going to translate a single query into multiple queries. It says you are an AI language model assistant. Your task is to generate 5 different versions of the given user question to retrieve relevant documents from a vector database. By generating multiple perspectives on the user question, your goal is to help the user overcome some of the limitations of the distance-based similarity search, provide this alternative question separated by new lines, and then put the original question there. Right? And then after that, we can do some simple parse function to pass out the queries generated from this prompt into a list. Right? So we create this query gen. It chain together the perspective prompt template with the chat model, and then with the parse queries output. And then we can invoke a question. It's still the previous question we used. And let's see how the list look like. Right? So here we see that it creates 5 queries based on the original question, and it put them in the list. The first is number 1, it is necessary for faculty to disclose the AI policies to students considering the ideal weather for a walk. That's not very good. Second, how important it is for faculty members to communicate AI policy to students, especially on a day like today with perfect weather for a walk. 3, in light of the beautiful weather, should faculty make the AI policy known to students or keep it undisclosed? 4, given the perfect weather for a walk, it is advisable for faculty to declare the AI policies to students. And 5, should faculty consider sharing the AI policy with students even on a day when the weather is perfect walk? This is a little bit hilarious because I intentionally use a terribly written prompt. But you see the idea, right? And then I create a function called getUnique-Union, which take the list of generated queries and retrieve the most relevant docs for each of them in parallel, and then combine them to get a unique union of all the retrieved relevant documents. Okay. So here I use a trick. And the trick was actually invented by the author of the book that I told you before, called Learning LangChain, in pre-publication release in O'Reilly Media. If you're interested in that, definitely purchase that book. So here, the trick the author used is to flatten the list of lists so that it can deduplicate them by including them in a dictionary. You know, in a dictionary, each key must be unique. So by including the page content as a key, if the two documents retrieved are exactly the same, then it's going to just keep one copy of it. Right? So that is just a very simple way to avoid no duplicating retrieved documents. Right? So so this function is going to be implemented after retrieve the documents. So that now we are ready to build the retrieval chain. Retrieval chain, the feeders of the retrieval chain is going to be query gen. Remember, query gen generate a list of queries based on the original query, and then it feeds the list to the retriever. And notice that here, instead of using retriever invoke, we use retriever batch because this is going to parallelly processing and retrieve documents based on each of the queries in the list. And then finally, based on the retrieved documents, we do some combination and remove any duplicates by including them in a dictionary. Okay. So that's it. If we run this, we build the retrieval chain already. And now we are ready to build the pipeline for the multi-query chain. We build that in a function. So we call multi-query chain. It asks for a question, and it is going to use the query chain to invoke the question and create a list of many versions of that. And then we are going to use the retrieval chain we just built on the list of queries. And then we can invoke the prompt template. The prompt template is here. That we sorry, the prompt template where we define the prompt template. I think we should instead use this perspective prompt template rather than using the original prompt template we created. Sorry for mistake, it should be this. And invoke the documents, document will retrieve documents, and the question will be the question. No, actually, this is the previous one was correct because here we are asking for the context and also the question. So it should be the previous prompt template that we create, which is here, right? Answer the question based on the following context. So the context would be the retrieved documents, and the question would be the original question. Sorry for the confusion. And then we invoke the prompt, the model to generate a response. Okay, so that is correct. So if we do that, it's going to take a little longer because now we are in the parallel fashion of retrieving documents. But the final answer is good. Faculty should declare the AI policy to their students as it is recommended in the provided context. Okay. Okay. So I think we'll stop here. I'll make another video in which we are going to talk about other more advanced RAG systems built upon the naive RAG. So stay tuned. I'll come back with another video.